Hello, everybody, and kia ora. We have more than 400 people registered for today's session. Welcome to you all, and thanks for joining us. In today's session, we will talk about documentation we've recently published to encourage the use of recycled crushed glass in transport infrastructure. My name is Ekaterina. I'm a communications officer at Austroads, and I will be moderating today's session together with one of the presenters, James Grenfell, from the Australian Road Research Board. James will moderate the Q&A at the end of the webinar. First of all, we would like to acknowledge the Australian Aboriginal and Torres Strait Islander people as the custodians of the land from which we are broadcasting today. I pay my respect to all this past, present and emerging. I also acknowledge the Treaty of Waitangi and Maori as the regional people of New Zealand. A little bit about Austroads. We are the collective of Australasian transport and traffic agencies, and our focus is to support our member organizations to deliver an improved road transport network. The project that we are focusing on today was delivered under the Transport Infrastructure Program, which is managed by Ross Guppy. A bit of housekeeping. Our presenters will speak for about 40 minutes and then we will have a Q&A session for 15 minutes. We have a few handouts for you for today's session. Please download them from the handout section of your sidebar, which you will find on the right-hand side of your screen. To send us your questions for the Q&A, please use the questions icon on that sidebar. If your question relates to any particular slide, include the number of that slide in your message to help us answer your question as best as we can. Also, let us know if you are experiencing any technical problems, but just a quick tip, if you lose sound or your picture freezes, the issue is most likely with your internet connection. So leaving the session, closing your browser and rejoining again via your email registration link usually helps. This session is being recorded and we will let you know when the recording is available on our website. If you listen to podcasts, you can also find Austroads in your podcast app. So our presenters for today are Dr. James Grenfell and Dr. Didier Baudin. James has more than 16 years experience working on various projects related to pavement materials, both in Australia and the UK. He is a principal professional at the Australian Road Research Board, and much of his work is focused on Austroads projects, including looking at improving the knowledge of foamed bitumen stabilized pavements and the use of lightly cemented materials in pavement construction. And our second presenter, Didier, is a principal technology leader at the Australian Road Research Board. His research interests are in the areas of pavement material characterization, pavement response, performance modeling, and pavement design. Didier's work on Austroads projects deals with rut resistance characterization and prediction of unbound granular materials response. And for the Q&A, we will be joined by Austroads project managers Arthur Apostolopoulos and Sam Henwood. And on that note, I will hand over to James.
Right, hello everybody, and thank you for that introduction, Ekaterina. As mentioned, my name is James Grenfell and I'm a principal professional here at ARRB. And I'm going to start off by going through an introduction about this work to increase the use of recycled glass in road infrastructure. So first of all, an introduction to the project team. So this project has been managed by two Austroads project managers, Arthur Apostolopoulos and Sam Henwood. The project leaders from the ARRB side are Dr. Didier Baudin and myself, James Grenfell. And we have two quality managers for this project who are Dr. Michael Moffat and Tyrone Toole. As part of this project, a project working group was set up to support the project and also to provide technical reviews. This consisted of a number of environmental experts as well as technical experts from across the different states and territories. And then additional reviews were carried out by going through Pavement Task Force. So to put this in a bit of context, why do we need to look at glass? So in March 2020, COAG agreed the Australian government to regulate the export of glass and plastic and other recycled materials such as tyres and paper. And the Transport and Infrastructure Council, TIC, noted the opportunity for transport infrastructure projects to repurpose some of this waste. So to support the COAG waste export ban and the National Waste Action Plan, Austroads commenced a programme of work to develop guidelines and specifications on the use of crushed glass in road construction by the end of 2021. So, as is the case with all projects, we should respect sustainability principles, and this involves reduction of the amount of waste that we're generating, to reuse waste in its original intended use where possible, and where not possible, to recycle the waste. So what can we do with all this glass that ends up in landfill? And obviously, the purpose of this project is to look at whether we can use crushed glass as an aggregate for civil construction. So now moving on to the project objective. So the main project objectives are to increase the use of crushed glass in road infrastructure. And this has been done through the development of an Austroads technical specification to assist road agencies and local governments to use more recycled materials in their road construction activities. In support of this document, technical report was also developed to give the underpinning knowledge on the limits and also the reasoning behind the technical specification. And also produced was a processing guidelines document. This work was funded through an Infrastructure and Transport Senior Officials Committee project, and as mentioned by Katarina, sits as part of the Austroads Transport Infrastructure Programme under Ross Guppy. So now to talk through the project scope and methodology. So in terms of scope, the project assesses opportunities for the use of waste glass as a bedding sand replacement, and also for use in non-structural concrete and pavement applications, in road drainage applications, also within embankment fill and landscaping applications. The methodology involved was based on reviewing existing best practice and current specifications to help develop harmonized specification for Australasia. So this work has taken into account the work health and safety and also environmental perspective, and also considers the material engineering requirements for the targeted applications that I mentioned a moment ago. So during the project initiation, a stakeholder engagement session was organised. And this slide provides some of the thoughts and feedbacks on the use of recycled glass from that stakeholder engagement. So some of the key messages are placed on this slide, and some of the things that the people suggested we needed to think about were things like highest and best use. So dumping in earthworks potentially may have limited value, and that we should be aiming at upcycling recycled resources where possible. Another note was that the economic benefit is very dependent on transport costs. There were question marks about certainty of supply, and that's something definitely to be thought about. If we're using recycled crushed glass in a large number of projects, potentially we could end up using up all available stockpiles. Another thing that was noted was that material can be more difficult to work with, especially in terms of things like odor, and it can be heavy when wet, and even more expensive when it's washed. But we also need to be thinking about education for our engineers rather than mandating its use. Right, now I'm going to hand over to Didier Baudin, who will take you through the next section of the presentation.
Good afternoon, everyone, or good morning, depending on where you are. I'm Didier Baudin, Principal Technology Leader at HAB, and I will take you through the key findings of the technical report APT 362, which was published recently, which summarizes the technical basis of the development of the ATS 3050, which covers the supply of recycled crushed glass for transport infrastructure. I will present the important outcomes and put in perspective of current practice. And after that, James will be diving into more detail about the specification requirements. So as introduced earlier, the aggregate we are dealing with are derived from the curbside recycling, commingled or separated, collection of glass. And if they aren't recycled as glass containers, they can be recycled as aggregate, and for that they are crushed to produce a consistent grading material. The contamination level of this type of material can be managed through sorting and, if necessary, washing, depending on the feedstock and how uniform it is or contaminated it is. And in general terms, the end product is usable as an aggregate or sand replacement in civil application. We went through an assessment of the environmental risks of using this type of aggregate in road infrastructure. And it has a strong basis from past research and past regulation around the use of this material in this type of application. And in particular, the EPA requirement set in 2014, which has been further adopted by TMR, Transport and Main Road in Queensland, in the development of the MRTS 36, set the basis for us to harmonize the requirements for Australasia through this specification. It basically contains three type of requirements. The first set of requirements are on the metal contents, which include mercury, cadmium, lead, arsenic, chromium, copper, molybdenum, and nickel and zinc. And also an assessment of the total organic carbon, which is an indication, an assessment of the organic water contaminants, and an indirect assessment of any dissolved minerals which can be contaminating the aggregate through electrical conductivity. So the methodology was based on benchmarking the requirements, the current requirements through different agencies, from EPAs or other agencies, to set the limits which would be adopted by nationally and including New Zealand for the recycled crushed glass. As I said, the requirements set by the New South Wales EPA were key in setting this limit. They were the most stringent in most of the cases, and they basically included maximum averages value and absolute maximum values, which shouldn't be measured on any sample from the stockpiles. And maximum averages are managed through sampling conditions detailed also in the specification. It was important as well to summarize the current best practice with respect to the work and safety risks and mitigation measures to protect the workers and more broadly the communities. Foundation work from the Winder report undertook a risk assessment and drafted an MSDS for recycled crush glass for the transport infrastructure. And this work was later supplemented by other studies. An important aspect is that recycled crushed glass, it's like pure silica, doesn't pose an increased risk of exposure to respirable crystalline silica, because the glass from waste containers and bottles, etc., is made mostly from amorphous silica, which doesn't present the same harm and the same risk with respect to the silicosis. As any aggregate, the risk of abrasion by direct contact are manageable through the use of standard PPEs, goggles, gloves, wearing long sleeves, etc. Another thing which appeared during the early trials is that by reducing the size, the maximum size of the particles to 5 millimeters, was increasing the cubical shape of the particle, reducing the number of flaky particles, which can pose potential risk for cuts of skin or any exposed surface. So by reducing this size, the risk of cut is significantly reduced, and that has been set in as a requirement. The dust or airborne contamination can be reduced when the material is placed wet, and a moisture content around 6% has been found as a good moisture content of storage and handling. And when odor is an issue, it has been the case in placement in confined spaces like trenches. The washing of the recycled crushed glass reduce the potential odor and make it easier to work with. Now I want to go more on the engineering side of things, where here I show you some typical products which we saw the particle size distribution from. So this chart a typical particle size distribution graphs, where we've got the sieve side on the x-axis and the percentage passes as a mass on the y-axis. And in terms of material produced, we can find some typical 5 millimeter well-graded material as the blue curve. Some other producer would sieve the material with a maximum passing at 3 millimeter. Some other product can be found with almost retain on the 1 millimeter sieve. So that's a very coarse type of aggregate from 1 millimeter to 5. So a range of products are produced currently in Australasia and are already used on the market. And now we'll have a look at what the technical requirements are found to be. So we undertook a review of national and international practice, and it's not new technology, and we summarize the main characteristic, physical properties, which can be found in the literature in terms of particle size distribution, shape, and bearing capacity, the plasticity of the material. For recycled crush glass is a particularly non-plastic material, because if it's not contaminated, it has no plastic fines in it. We summarize data available in terms of compactability, permeability, bearing capacity, and also typical values found for electrical conductivity. We have mentioned before that it can be varying, and it can also be a measure of a mineral content. And for electric applications as well, which was a bit beyond the scope of this project, the thermal conductivity can be an important factor to dissipate the heat from the electrical conduit. But it's definitely out of the scope of this specification for high tension, high voltage application, and some specific specification for most grid, for instance, ban the use for high voltage electric lines, buried electric lines. In summary, we found that compacted RCG had comparable properties to natural sand products, and there was no reason, and it was demonstrated by a number of trials, not to use it as a replacement for sand or incorporated in any granular materials. What really matters when we are talking about a 100% recycled crushed glass product is how the bearing capacity of the material, or its stability with time. And this is mostly obtained through its grading, so the particle size distribution, and how the material will reach maximum density. And it's generally achieved with a well-graded material, which has the highest density result. And so that has been used, and it's typical grading we have, for instance, in the requirements of the specification for the recycled crushed glass used as a bedding sand. However, when it comes to drainage application, there's another function we're after with these materials, and we are targeting more space between the particles to let the water flow, and not to build up suction too much through the aggregate packing. And therefore, in that instance, we will be targeting some gap graded or single size type of grading curves for drainage application. Just to mention that some products I showed earlier don't necessarily meet the requirements of continuously graded material, but it's easy to recombine them. For instance, we have a coarse and passing 3 mil, two different products with a 40-60% blend. You have a product which end up being a well-graded material, so it can be tuned to the desired target gradings. But also, the recycled crushed glass can be used not only at a 1%, 100%, but it can be added to a range of granular materials, primarily for crushed rock, for road bases, road subbase. So the specification in different jurisdictions vary from a 5 to 50% allowance, depending on the material type or the performance requirements in terms of traffic loading, or if it's an highly stressed layer. It can be used as well as a constituent in concrete mixtures, and the scope of this work was mostly focused on non-structural concrete or concrete pavement. It can also be an additive in asphalt mixtures. It becomes part of the mix design, and there are some maximum requirements which can allow to manage potential risk of stripping. And it's totally suitable, of course, to be added in terms of earthworks, embankment, and landscape application. But we have to bear in mind that we want to maximize and upcycling the use of this material, and it might not be the best end use of this material. Now I will hand it over to James, and I remind you to put your question in the question box for later Q&A. Thank you very much.
All right, thank you, Didier. And now I'm going to be moving on to talk about the Austroads technical specification. So this has obviously been developed as part of the project. And just to go into an introduction to the development of the specification, this has been supported by decades of research, and also field trials and implementation has paved the way. This dates back to things like the Packaging Stewardship Forum initiatives back in 2006. Specifications for recycled crushed glass as an engineering material developed by Bob Andrews back in 2010. It's included things like trials of recycled glass as a pipe embedment material, undertaken by the Department of Environment and Climate Change back in 2007. As Didier mentioned before, Department of Transport and Main Roads Queensland's MRTS 36 specification has been instrumental in the development of the specification. And also, obviously, we've been looking at what's been done overseas. So when glass hasn't been reused, i.e. converted back into glass containers, similar technical uses have been found overseas. So specifications for natural aggregates tend to set the minimum requirement for recycled crushed glass when used as a glass sand, and this has led to the development of a harmonized requirement for recycled crushed glass. So now I'm just going to talk through the structure of the developed specification. So in terms of contents, it contains some information about the scope where the specification is applicable to. It provides a number of definitions of some of the key phrases within the specification, and then goes on to list a number of reference documents. It then talks about the quality system requirements, and then it goes into some of the key aspects. So the key aspects are things like the glass source, the chemical and other material requirements, its properties for use when used as a granular material, and then some of its properties when used as used in concrete, including some general requirements, and then it touches on the alkali silica reactivity. Finally, there's some information about testing and conformance. So how often materials need to be tested, and what are the amounts or what lots are needed to be tested to meet that conformance. And then it goes into some annexes that cover hold points and witness points and records. So first of all, if we talk about the glass source, so there's some key requirements in terms of the sources of the recycled crushed glass and also the contamination limits. So recycled crushed glass must be produced from food and beverage container glass or window glass, which means that the source material must be essentially free from glass from the following sources. And these sources include cathode ray tubes, fluorescent and incandescent lights, glass recovered from electrical equipment, glass recovered from laboratory sources, porcelain products and cooker tops, and also glass from hazardous waste containers. So again, this is one of the reasons for this is to reduce the amount of contamination that could be in the resultant recycled crushed glass. So recycled crushed glass should be free from contaminants, and some maximum average concentrations are reported in table 5.3, which is shown on the right-hand side of this slide. So there's some limits for certain contaminants, including metal and ceramics, with average maximum concentrations of 0.25% for metal and ceramics, with an absolute maximum concentration of 0.5% in any particular measured sample. This is similar for brick, plaster, clay lumps, and other friable materials. And there's also a set of limits for contaminants such as rubber, plastic, bitumen, paper, cloth, paint, cork, wood, organic matter, and other deleterious materials, with a maximum allowable average concentration of 0.3% or an absolute maximum concentration of 0.5. And these contaminants can be measured through Transport for New South Wales test method T281, which is a loss on ignition test. Also, the recycled crushed glass must be free from any putrid odor. So now moving on to chemical and other material requirements. Again, and this is, I guess, reiterating some of the information that Didier talked about from the technical report. But in the specification, there's some limits on chemical concentrations of certain metal contents. So those metals are including mercury, cadmium, lead, arsenic, chromium, copper, molybdenum, nickel, and zinc. And again, there's maximum average concentration limits across a set of samples. So typically 5 historic samples over time, but with some absolute maximum concentrations for any singular test. There's also some limits on the total organic compound, organic carbon content. So this is looking at organic water contaminants. And also there's some requirements in terms of electrical conductivity, and the electrical conductivity relates back to contamination levels of dissolved minerals. So this table is within the specification and needs to be followed to understand what the chemical and other material requirements are. So the next thing I'm going to move on to is the properties for the recycled crushed glass for its use in granular materials. And there are certain quite specific grading requirements. So again, Didier went through the background in the technical report as to why gradation is important for some applications. And there's also some general notes about the recycled crushed glass particles. So they should be cubic in shape and free from sharp edges and elongated particles. And their particle size distribution should be determined in accordance with AS 1141.11.1. but depending on the end application, each potential application has been designated a grading classification type. So as part of this work, we looked at a number of different end applications for the recycled crushed glass, and those included bedding and haunch of drainage pipes and conduits and services, and also side zone and backfill of drainage trenches. And the requirements there is for a type A grading. Then it could be used in bedding for segmental or block paving, and the requirement there would be a type B grading. It can also be used in joint filling, so filling voids between individual segmental blocks or block pavers, and for this a slightly finer grading, a type C grading is required. There's also opportunities for it to be used as a drainage medium, and this time a type D classification is specified, and there's opportunities to use it in embankment core zone fill, where a type E gradation would be classified, and in landscaping applications where we'd be looking at a type F grading classification. So when we're considering it for use in embankments, it should only be used in the core zone of embankments and not placed within upper or outer zones of the embankment. And another key thing to note is that these grading classifications apply when recycled crushed glass is used in specific applications, and they do not apply when recycled crushed glass is used as a component of a blend. So in this case, I'm talking about where recycled crushed glass can be used within granular materials for road base and sub base, or potentially within asphalt applications or concrete. When those applications are considered, we do not need to meet the same grading limits as specified in the tables. So the table on the right is just giving some information about the different grading types. So type A is applicable for bedding and backfill, etc. Type B, which is slightly more restrictive, is for bedding and bedding of segmental or block paving. There's a finer grading, type C, for joint filling. Type D, which is for drainage medium, is controlling the glass particle size in terms of almost making a single-sized product, so still passing 4.75, or all of it passing 4.75 millimeters, but pretty much everything retained on a 1.18 millimeter sieve to remove all the fines to allow it to be free draining. And there's much lower restrictions in terms of embankment fill and landscaping applications. Right, there are also a number of properties when recycled crushed glass is to be used in concrete, and these are very specific. A lot of this is to do with preventing certain deleterious reactions that can occur with certain contaminants when recycled crushed glass or specific aggregates are incorporated into concrete. So things that we need to be mindful of are things like sugar in the aggregate, sulfate content, chloride content. There's also some requirements for methylene blue absorption values, which relates to clay content. So as mentioned, the alkali-silica reactivity is a major challenge. So we want to prevent that alkali-silica reaction from occurring in concrete when recycled crushed glass is used as a fine sand replacement. So alkali-silica reaction is known as concrete cancer and causes silica to react with the alkali in the concrete. And this can create microcracking within the resultant concrete, leading to strength losses. So the alkali-silica reaction potential in concrete can be determined through the composition of the recycled crushed glass. And RCG is identified as having a potential problem if it's tested in accordance with either AS1141.60, 60.1 or AS114160.2, which are methods for sampling and testing aggregates potential to alkali silica reactivity, either the accelerated mortar bar method or the concrete prism method. And if the RCG is identified as having a potential ASR problem, there is also some advice out there for treatment control, and that treatment control should be carried out in accordance with SA HB 79, which is relating to alkali aggregate reaction, and guidelines on minimizing the risk of damage to concrete structures in Australia. Now I'm just going to touch upon some of the contents of the guidelines document. We don't have too much time, so I won't go into too much detail. But essentially, the guidelines document provides some general information about how glass should be processed to meet the requirements of the RCG specification. And if we to consider processing of glass, we can be looking at fairly basic processes through to very complex processes. So at the sort of more basic level, we could just be including some primary crushing and then a certain amount of processing in terms of removing contaminants. But in more complex systems, we could end up with a number of crushing stages to meet very specific grading requirements. And it could also include some washing requirements, and that can be more applicable to certain applications, as we'll touch on later. So in terms of crushing, it can involve a number of steps, as I mentioned, but typically we can meet the requirements with one step, and an impact crusher is potentially the best way to do this. It tends to produce a more uniform particle shape, which is generally cubical in nature. It produces more fines, which can be advantageous for certain industries, especially hot asphalt producers. It can incorporate a number of interchangeable sieves, which allows us to have more control over the end particle gradation. And also, damaged hammers can be quickly replaced in this type of device. So in terms of processing, again, there's a number of stages that are typically required. So the first stage is optical sorting, and often this is undertaken manually to remove some significant pieces of contaminant. Then we'd often involve a magnetic belt sorter to remove ferrous or magnetic materials. An air classifier is typically used to separate out materials of different densities, and this is particularly useful for separating out things like paper and labeling, things with much lower density than the glass. And eddy current separators can be used for separating out non-magnetic metals. So by the time the glass has gone through all of these different processes, it's normally relatively contaminant free. But there is also that option to go through cleaning processes. And dependent on the end application, that is of course optional. It's probably more suited for concrete applications where we're very concerned about the sugars content, for example, and some of the contaminants that might lead to alkali silica reactions. And it can also be used to reduce odor. And so if odor has been identified as a particular problem for our recycled crushed glass, it can be reduced by putting it through a washing process. It could also be applicable for asphalt applications, especially if we're concerned about odor from asphalt plants. I guess another concern for asphalt plants is the potential risk of fires if there's remaining paper left over from labeling, etc. But that should have been removed by the air classifier in the processing stage. So one thing about cleaning is obviously it increased costs, and therefore it can make our recycled crushed glass less sustainable to use. So now I'm going to move on to some concluding remarks. So the major outcomes from this project obviously are the Austroads technical specification, so ATS 3050, which sets the requirements for the safe supply and use of recycled crushed glass. There's also the supporting technical document and the guidelines for the processing of recycled crushed glass, and that provides an overview of RCG production and some broad requirements and processing steps to reach the specification requirements. So all of this work promotes the harmonized practice for the use of recycled crushed glass in transport infrastructure, and it's available now, so download it and start using it. And now we're going over to the question and answer session. Right, just a first question that we've received. Can you comment on the technical issues associated with recycled crushed glass usage in concrete? As I'm aware, it can be used in some applications, but not all. For example, structural concrete.
Might take this one. Thank you for asking this question. So as part of the scope of this work, our targeted application were non-structural concrete and concrete pavement. Some research has taken place for investigating the use of recycled crushed glass in structural concrete, but it's not the purpose here. What we are more talking about is general concrete, non-structural for curb and channels, footpaths, share paths, traffic island with no traffic, footing for sign support, poles, lighting columns or traffic signals, which are by nature have a low requirement, and the RCG in the specification is fit for purpose for this type of use. When it comes to concrete pavement, Transport for New South Wales, for instance, has been a great user of rigid pavement and concrete pavement. And when RCG is used, it's used as part of the fine fraction of the concrete. And there's, for instance, in the Transport for New South Wales specification, a maximum allowance of 15%. And when the recycled crushed glass meets the specification, it can be used as a part of the component of the concrete to make the concrete for the road. To give you an idea, the fine is a passing 4.75 millimeter, which represents about 40 to 50% of the grading of the whole mix. So that's 15% of this 40 to 50%, which could be recycled crushed glass, complying with the specification. Hope that answers the question.
Thanks, Didier. Yeah, there's quite a number of questions that we've received as well. I think some of them potentially were actually answered further through the presentation. but I'm going to try and cover off as many of the interesting questions as we can, and obviously any questions that we don't get round to answering, there'll be a formal response to the questions. One of the questions we received is, would you suggest the estimated potential supply of glass sand in the Australian market, and approximately how much percentage could be achieved to replace natural sand? The cost for glass sand is likely to be higher than natural sand, which might limit the application of glass sand. What kind of means could be adopted to implement the application of glass sand? I might start off by taking a bit of that one. I mean, I guess obviously it depends on the end application in terms of the amount of RCG that can replace natural sand. And in some of these applications, they're 100% replacements. In others, it's limited by the end application. There's been some questions about asphalt as well, so I'll maybe cover that question a bit later on. In terms of the cost for glass sand, typically it's in the ballpark region of natural sand, and therefore some of the drivers could be the availability of natural sand in certain geographic locations. So we definitely see that in some locations there's limited availability of natural sand, and therefore it becomes more desirable to incorporate recycled crushed glass. There's also obviously opportunities to keep the cost of the processed glass down. So as I mentioned before, the washing step is suggested as optional, and then using that washing step obviously increases the cost of the glass, but it also opens up other potential applications. I don't know if Didier or anybody else wanted to touch upon this anymore.
I think there's also, and maybe Arthur can complement on that, there are also other mechanisms which will help promoting the use of recycled glass in lieu of a natural sand. Would be some policies like there's in Victoria, for instance, recycle first, where you get to look at recycling options before you go to the natural aggregate, and that's part of the procurement process, that there's a mechanism to favor the recycle aggregate. So that's another mechanism can be used.
And also, James, be worth mentioning that significant cost in using sand is the actual transportation of the sand or recycled crushed glass to where it's required. So if you look at say a city like Sydney, there are no real sort of quarries in Sydney as such. Everything's brought in from outside the Sydney Basin. Whereas there's a lot of yellow bins that collect recycled crushed glass and processing of that in the city. So there is that distance and transportation cost that depends where you need it and where the source is.
Exactly. So,
and in Melbourne, just to sort of add there, we've got a sort of similar situation. We're out in the west of Melbourne, where a lot of the glass gets recycled and repurposed. There's certainly a cost differential between the west of Melbourne versus the east of Melbourne, where a lot of the natural sand pits exist as well. So, but we are seeing contractors out in the west engaging with us to incorporate that recycled crushed glass in asphalt.
Yeah, thanks, Arthur. Yeah, definitely each application needs to be considered kind of on a case-by-case basis, and taking into account transportation costs, and transportation costs are likely to be one of the most significant. And therefore there's going to be areas where the use of recycled crushed glass is much more attractive down to reduced transportation costs, and other areas where there's going to be increased costs by using the recycled crushed glass. There was a point about page 15 in the slide, so I think this is relating to some of the stuff that you were talking about, Didier. And it's, how is recycled crushed glass treated to become more amorphous, or is recycled glass classified as amorphous silica due to its atomic structure, no matter whether it's treated or not. I think I'll let you cover that one, but I'm happy to step in.
I'm not too sure about the atomic structure we are talking about, but basically from the sources of glass which are covered, which are processed through this, we are dealing with amorphous. So in terms of structure, like structure of the glass itself, it's amorphous glass. But yeah, I'm not sure if it's.
Yeah, I mean, essentially, glass is an amorphous material, and therefore that's one of the reasons why it doesn't have the problem of the crystalline silica. So it doesn't need to be treated in any way; it just exists in an amorphous phase. It's going to come on to some of the questions around asphalt. So one of the questions is saying that the presentation suggests the research is more orientated towards RCG and concrete. Has sufficient research been done in using RCG and asphalt also? Grading for RCG and asphalt has not been suggested in this presentation. That's a good question. Maybe I'll start off and I'll let the other guys join in as well. Initially, when the scope of this project was developed, asphalt was considered out of scope. However, the specification has been developed that the same product could be used within aggregate blends for asphalt. There has been a lot of research in the use of recycled crushed glass into asphalt and suggestions on what those absolute limits of recycled crushed glass content can be, and a number of states, if not all states, have limits around the allowable levels of recycled crushed glass, be that in intermediate and base course asphalt, and also now being introduced into wearing course asphalt at slightly lower levels. I don't know whether anybody else wants to comment on that particular question.
Yeah, I would just add that yes, certainly in Victoria and with the Department of Transport specifications, we've had recycled crushed glass introduced into our base layers of asphalt for some time, and we're currently working with some of the stakeholders to see what we can do in terms of introducing it into that wearing course area as well, James. But certainly, yeah, no grading was provided because it was always considered to be blended in with other natural aggregates as well. So there was no need to specify a grading or an envelope in the use of asphalt.
Thanks, Arthur. Maybe we've only got time for about one more question. I don't know what Ekaterina thinks, but anyway, one of the questions was, can you confirm the type D drainage medium is intended for subsoil drainage applications? I mean, essentially, one of the reasons for the drainage medium was also around sort of drainage layers which could sit above or between subgrade and subbase layers within pavement structures. And we've seen examples of where that's been trialed in certain local government authority constructions. So again, it's all about producing a gradation that doesn't have too much fines in it and so is free draining from water. But hopefully that helps answer that question. Ekaterina, should we think about wrapping up?
I think we can go carry on for another 5 minutes. We still have almost 200 people on the line, so yeah, we can take another 5-10 minutes if you don't mind.
Yeah,
5 maybe would be enough.
Carry on and have a look through some of the other ones.
Maybe James, add on to the drainage application, we identified some use as well around the country as anti-capillary rise, like a drainage blanket as part of the pavement layers to stop capillary rise. So that's another application which could be further developed.
Another question we had was, in a general sense, surface friction is pretty low in glass particles. Have you checked the packing characteristics and stress distribution of RCG layers, specifically in pavements? I don't know whether, Didier, you want to comment on that one a bit?
So the project itself didn't include laboratory testing. So we rely on the test results from the literature, and when compared to natural sands, we found that even the shear strength parameter were comparable compared to natural sands. But yeah, again, depending on the petrographic nature of the natural sand, it varies in a range. But it's definitely it was definitely found for purpose for the designated applications which are covered by the specification.
And yeah, there was another question relating to particle interlock again. So yeah, I mean, definitely other research work that we've done has suggested that recycled crushed glass has a lower specific surface area than other aggregate types. So potentially that can mean reduced particle interlock. It also has potential implications for its use in asphalt as well, that due to that lower specific surface area, it could have some implications in terms of its resistance to moisture damage and stripping. So generally, going back to moisture damage and stripping, that the recycled crushed glass, if it was clean, it should perform quite well in terms of its adhesion to bitumen. But the main reason why it might not be as good as certain other aggregates is more down to its lower specific surface area. There was a question, can you elaborate on the use of RCG as landscaping? I understand the use for paving, but not clear on the intent of landscaping. I don't know whether you wanted to go on that one for a bit, Didier?
But landscaping can be quite broad. I guess the objective here is not to ban its use in landscaping application, and it's to make best use if that's the only application for the recycled crushed glass in the area. It can be used as a sand replacement in landscaping applications, which are obviously non-structural, and yeah, and takes the opportunity to use a recycled resource instead of extracting sand from the earth for more construction. So that's to be open-minded in terms of the range of applications, and it's up to the end user to select where the best use is.
Another question that we had is around compaction and testing requirements for recycled crushed glass as a sand replacement in pipe bedding and side support. Whether you could comment on that one as well, Didier?
So the requirements will be the same as the requirements for the backfilling, bedding backfilling applications, as I will set the requirements for the product placement. So instead of having a natural sand supplied, it's just replaced by another type of aggregate. But the requirements will be covered by the designated application.
There was also a couple more questions related to its use in asphalt mixtures. One of them is when using as a constituent in asphalt mixes, has any investigation been carried out into the possible impact on the safety of those who ride motorcycles? Could it affect asphalt's traction or abrasion properties? I mean, essentially, the recycled crushed glass it's a passing 4.75 millimeter product, and it's generally cubical in shape. It behaves in a very similar way to the natural aggregate or natural sand component of aggregate that it's replacing. I think historically, glass might not have been processed to such a fine product, and historically there were some concerns about including it in asphalt wearing course as it reduced the amount of friction in the surface. However, now we're processing to 4.75 millimeters and below. That's no longer an issue, and there would be no impact on the safety of road motorcyclists, for example. If you were to fall off, it would be exactly the same as falling off on a conventional road made from ordinary aggregates. I don't know if anybody's got any comments further to that.
Yeah, that's been the experience in Melbourne as well, where we've got a couple of sections of road that were resurfaced, and there was glass introduced into the wearing course, and subsequent skid resistance testing has shown no difference between the two. And what you said before, James, the fact that we've got a 4.75 maximum size, and the fact that crushing these days is a lot more sophisticated than what it was. The days of having shards of glass in there are now way behind us. So it really does come down to a similar type of look and feel to sand, basically, of a cubical nature.
Probably also worth mentioning, James and Arthur, that we certainly use it in the wearing course in New South Wales, but it's at a much lower percentage than in the deeper down layers. So we would limit it to 2.5% of the total mass. So there's other particles of sand sized in the greater asphalt mix that you'll find on the wearing course. So, and like Arthur, our tests of skid resistance and reflectivity, show that it's working for us at those sort of amounts.
Thanks, Sam. And again, I guess following on from that, there was also how about its use in asphalt? What size of crushed glass will be applicable? So we've just mentioned that, but will there be any issue with the glare from the road pavement if glass is used in the asphalt mix? And again, the way that the glass is crushed and processed, and the fact that it's essentially combined within the asphalt mixture, there's not going to be any glare issues with the incorporation of recycled crushed glass into asphalt. I guess potentially if you looked at it very close up, you might be able to see some slightly different type of aggregates within the mix as the asphalt's.
James, we can't
hear you.
Something is happening with the audio. I've just lost my sound and then it came back, and now we've lost James.
I wanted to add that there has been recent research in Queensland in an eco project where a safety assessment has been done with a nocturnal assessment with light reflection, etc. So watch this space, and if you want more information, generally the NACO reports are publicly available on the website. Not sure if this one is available yet, but you will be able to find the direct information.
Thank you. We still can't hear James. Unfortunately, his audio is not available. And I'm not sure if James can hear us.
Doesn't seem like it.
Doesn't seem that way. Well, all right, it's 2:10, and I think we will wrap up here. And just before we all go, a few words about our future webinars. As you can see, we have a number of sessions coming up. You might be particularly interested in the session next week about a new laboratory fatigue relationship we've developed to better predict the performance of formed bitumen stabilized materials. So for more information on all of the sessions and to register, please visit the Austroads website, and you can also subscribe to our news alerts. And as usual, after we close out today's session, a questionnaire will pop up on your screen. Please take a couple of minutes to send us your feedback. Let us know what you liked or didn't like about the session. It really helps us to know what suggestions you have for future webinars as well. And once again, today's session is being recorded, and we will send you the link to the recording when it's published on our website. Thanks again, everyone. Stay well and safe, and enjoy the rest of your day. We will see you next time. Thank you.